Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered if AI can truly understand us, or if it is just faking it? This paper dives deep into that exact question, exploring how we can make sure artificial intelligence aligns with what humans actually value, not just what we say we value. Imagine AI getting super smart, like super helpful assistants. That sounds amazing, right? But how do we make sure they're actually on our side, that they understand our complex human values, and not just a simplified version of them? That is the big puzzle this research tackles. They argue that a one-size-fits-all approach to AI alignment, what they call universal alignment, just isn't enough. We need something more flexible, something that can adapt to different situations, tasks, and even different people. Think about it. We all have different priorities, right? What is super important to one person might be less so for another. And what is important in a medical emergency is very different from what is important when you're just chatting with a bot. So the idea of aligning AI to just a few basic values like helpfulness or harmlessness is too simple. This paper proposes we need context-specific alignability. That means AI needs to be able to adapt its values based on the domain, like healthcare versus entertainment, the specific task it is doing, and who is using it. This is where it gets really interesting. They're suggesting we move beyond just thinking about different users having different values, which is called pluralism, and expand that to include different domains and tasks too. So it is not just about aligning to a diverse group of people, but about aligning to the specific needs and values of the situation at hand. This all sounds really complicated. So how did they even begin to figure this out? They lay out a comparison here. Universal alignment is like trying to make one tool that works for everything, using a fixed set of unchanging values. They give examples like helpful, honest, and harmless. The methods include things like reinforcement learning from human feedback, RLHF, which basically means teaching the AI by showing it what people like and dislike. They also mention things like chatbot arenas, where AIs are ranked. But as you can see on the other side, context-specific alignability is dynamic and adaptive. It is about adjusting to different users' tasks and domains. First, let's talk about the traditional way of thinking about AI alignment. When researchers have tried to align AI, they often focused on a small number of core values. Think helpful, honest, and harmless. They also looked at different theories of human values, like Schwartz's theory of basic values or moral foundations theory, which are big academic ideas about what motivates people. But the big assumption has always been that aligning to these few core values is enough for AI to be useful everywhere. But here is where the paper says the universal approach falls short. They explain why universal alignment might not be the right goal. They point out that specialist systems often do better than generalist ones, just like a specialized tool is better for a specific job. So why would AI be any different? Another huge issue is that training AI to be universally aligned takes a massive amount of human feedback data. What happens when you don't have that much data, like in high-stakes fields like medicine? You can't adapt easily. This is a really crucial point. Often when we ask people about their values, they tell us one thing, but then they act differently. Think about saying you're not worried about climate change, but then taking a long flight. The paper highlights that general attitudes don't always predict specific actions. So, just because an AI says it aligns with a value doesn't mean its actions actually reflect that value in a real situation. We need to look at what the AI does, not just what it believes. And then there's this idea of alignment versus alignability. Alignment is usually seen as a fixed end state, something you train an AI to do once. But the researchers here argue for alignability. That means the AI should be able to change its alignment over time, adapting as context and human needs change. It is like having a smart assistant that learns and grows with you, not just a robot that does the same thing every time. They also touch on competence. Sometimes there is an objectively correct or competent choice to be made. If an AI is perfectly competent, it should make that correct choice, even if it is not what a human might intuitively do, especially under pressure. Humans make mistakes under stress, and if an AI just copies those mistakes, it becomes unaligned. This is a really nuanced point about ensuring AI doesn't just mimic human limitations. So, what does this context-specific alignability actually look like? The paper breaks it down into three key areas: domains, tasks, and users. First, domains. Imagine AI in healthcare versus finance. The values and rules are completely different. In healthcare, you have life or death decisions, ethical dilemmas, and a lot of specialized knowledge. Simply applying general values like honesty might not be enough. You need to incorporate things like laws, policies, and specific medical expertise. Fine-tuning models, which means adjusting them with domain-specific information, is seen as a way to achieve this domain-specific alignment. Next, tasks. Even within the same domain, like chatbots, the AI's job can change. Asking for a recipe is different from asking for a medical diagnosis. The user's goal and how they plan to use the information are key. This is where instruction tuning comes in, where models are trained to follow specific instructions for different tasks. They also mentioned that as AI becomes more agentic, able to act on its own, we'll need new ways to evaluate its context-specific alignment when it is switching between tasks. And of course, users. We already talked about how people have different values. This is where the idea of pluralistic alignment comes in, where AI can model and align to individual user preferences. The paper argues this is another form of context-specific alignment. It requires understanding what values predict these individual differences and finding efficient ways to align AI to them, similar to how we personalize other technologies. To bring all of this together, the researchers propose a 3-step framework for context-specific alignability. Step 1 is all about identifying the right values for a specific situation. They suggest looking at how experts actually make tough decisions in real-world scenarios. Instead of asking people abstract questions about their values, they recommend looking at concrete actions and decisions. They mention a method where experts describe difficult situations and what factors they considered, which helps uncover recurring value trade-offs. This way, you get values that are directly tied to actions and decisions, not just vague attitudes. And how do you assess these values? They propose creating specific scenarios that represent common judgment calls or trade-offs in a given domain and task. By presenting these scenarios to both humans and AI, you can directly compare how they make decisions based on those identified values and attributes. This is really about measuring expressed values through actions, not just stated values through surveys. Step 2 is about developing the AI algorithms themselves. They emphasize the shift from static alignment to dynamic alignability. This means AI needs to be able to adapt continuously as contexts change or as human knowledge evolves. They can't just be trained once and expected to stay aligned forever, especially in high-stakes fields. A big challenge is when you have limited data, which is common in specialized fields. They highlight research on algorithms that can infer user behaviors and values from small amounts of data. Interpretability is also key here, meaning the AI should be able to explain its reasoning. They mention techniques like chain-of-thought prompting and case-based reasoning, which can make AI decisions more understandable. They also stress the importance of incorporating domain-specific knowledge. AI often lacks the specialized knowledge found in areas like medicine or law. The paper suggests methods for embedding this knowledge, perhaps through retrieval-augmented generation or by referencing external documents like ethical codes. This allows AI to align with relevant rules and policies in real time without massive retraining. Finally, step 3 is about how we evaluate this alignability. The crucial part here is moving beyond just measuring whether an AI says it aligns with values and instead evaluating its actions and decisions. They argue that current evaluations often only measure stated values, which can be easily gamed. Instead, we need to look at demonstrated values through quantifiable actions and decisions in realistic settings. It is about whether the AI's behavior is consistent with the target values. A really important aspect they introduce is evaluating human trust and delegation. It is not enough for the AI to be aligned. Humans need to trust it enough to delegate tasks to it. They suggest looking at observable cues that build trustworthiness, like how the AI explains its decisions or its reasoning process. The goal is not just for the AI to be aligned, but for humans to accept it as a reliable decision maker. To make this concrete, they use medical triage as a prime example. This is a scenario where decisions are high stakes, often have no single right answer, and are heavily influenced by personal values. In this example, they show how you could identify specific values important in medical triage, like prioritizing moral responsibility versus prioritizing in-group status. Then you can align AI decision makers, perhaps using large language models or case-based reasoning, to these specific values. The final evaluation would then assess how much human decision makers trust and are willing to delegate to these aligned AI systems. The results they cite show that alignment indeed predicts trust and delegation preference in this domain. Now, what are the implications of this whole context-specific approach? It is not without its challenges and potential pitfalls. One big concern is that optimizing solely for user trust could lead to AI aligning with problematic values. Imagine an AI that gains your trust by subtly reinforcing your biases. This could be harmful and even dangerous. The paper stresses that we need boundaries and ethical considerations to prevent alignment with unacceptable values, even if users prefer those values. It raises the fundamental question of whether AI should align with any expressed preference, or if there are universal ethical constraints. Another point is that if AI can explain itself, that can build trust. But if the primary goal is just building trust, an AI might fake alignment by providing misleading explanations that sound good, but don't reflect its true decision-making. This can lead to miscalibrated trust, where we trust an AI more than we should. True alignment needs to be demonstrable, not just convincingly explained. The way humans interact with AI and are trained to use it also matters. Even if an AI is perfectly aligned, if users are forced to use it, or if they overtrust it due to how its interface is designed, it can lead to problems. The paper suggests that broader socio-technical design, including how AI is presented and integrated into workflows, is crucial for responsible use. So, to wrap up, the core argument here is that universal AI alignment is insufficient for the complex real world. We need context-specific alignability. This means AI needs to be able to identify, develop, and evaluate alignment with values that are relevant to the specific domain, task, and user. Of course, this approach isn't perfect. It is significantly more complex than universal alignment. Collecting the right data for localized alignment is harder. There is also a risk of fragmentation, where you end up with many different AI systems aligned to very different things, potentially leading to inconsistency and confusion. Malicious actors could also try to exploit this adaptability for their own gain, but the researchers believe the benefits outweigh the drawbacks, especially as AI moves into more critical areas. They highlight the need for more research into accurately identifying context-specific values, developing dynamic and data-efficient alignable algorithms, and creating robust evaluation methods that look beyond mere preferences to trust and actual delegation. Ultimately, the goal is safer and more reliable AI systems that truly understand and operate within human values. What do you think? Is this context-specific approach the future of AI alignment? Let me know your thoughts in the comments below, and if you found this breakdown helpful, don't forget to like this video and subscribe to RUBIN'S Mind Lab for more science simplified. We'll see you in the next one.